Hey folks, and welcome to a quick video on the cerebellum. So we're going to be looking over a bit of the anatomy of how the cerebellum is structured, and some of the cells involved in the cerebellum, and then we're going to look at both the function of the cerebellum, and how it actually can be examined by you when you're looking for a type of cerebellar dysfunction. Okie dokie. So we're going to start with macroscopic anatomy, and this is probably the most important stuff that I want you to get. Is the lobes and the zones. So the lobes are referring to what you actually see when you look at the cerebellum. So you can see there's an anterior lobe, there's a posterior lobe, and then there's a floccular nodular lobe in the middle. And it's important to note that it's going to be diagrammatically shown as on the bottom, but it's actually curled up inside. So it's anterior, despite the name of anterior lobe. The floccular nodular lobe is actually anterior, stuck inside. The anterior lobe is superior and the posterior lobe is inferior, basically. But ultimately, those classifications don't really tell you very much about how the cerebellum functions because they don't correspond to the functional areas. And so apart from the cerebellar peduncles, which of course provide most of our actual signaling through the rest of the brain, the other lobes don't tell us anything about which areas control what thing. What does tell us is basically the laterality. And sorry, I lied. The floccular nodular lobe is what we call the vestibular cerebellum. And that actually does correlate to its function. But for the main body of the cerebellum, we have two areas. So the spinocerebellum, which is basically the bit in the middle, and then the cerebrocerebellum. And so the names of each of them sort of actually corresponds to its function, and so you can hopefully start to remember and understand how they correlate. So the vestibular cerebellum, the vestibule part refers to basically the balance mechanism in your ears, which you might learn about sometime soon. And so this is basically to do with control. So, and what I mean by that is sort of resting control. So it's not conscious functional control of movements. It's more like the things that you don't even know are being done, but if you lost them, you'd be super uncoordinated. So if you have a vestibular cerebellum deficit, then you might have disorders of eye movement, you might have problems with balance, and you might have problems with walking normally. That's all really background sort of stuff. Your spinocerebellum, you can think of it almost as the spine is what controls the rest of the body and, deals with your actual movements. And so this controls your actual movements that are happening right now. So it's what stops you from having really clumsy, jerky, tremor sort of movements. That's the role of the spinocerebellum. And then the cerebrocerebellum, sorry, can't speak today, which is your lateral hemisphere, so the further out part of the anterior and posterior lobe. Those relate to, well, the cerebrum. And what does the cerebrum do? Well, it doesn't control the movements directly because everything is routed through these motor areas. Its main role and the benefit of your brain is that it allows you to plan movements, to modify them, to change them while you're doing them, and then to learn new movements. And so that is the main role of the cerebrocerebellum, is actually assisting with that. Okay, perfect. And so microscopic anatomy, you guys don't really need to know that much of this. There's a lot of detail if you want to jump into it, but ultimately most of it isn't that important for you to know. So stuff that is probably useful to know is probably the most important thing is the Purkinje cells, because those are basically your input. So we'll talk about the wiring on the next slide, but things come in, signals come in to the cerebellum in part via those, you can see there, the granule cells and the parallel fibers, which take it to the Purkinje cells, which are these big branching sort of tree structures. And then those Purkinje cells plus the original fibers from the rest of the brain, what actually controls the deep cerebellar nuclei, which are what generates the cerebellar function. So it's like the Purkinje cells are like the input sort of interface, and then the cerebellar nuclei actually do the sort of thinking per se. Okay, so again, in terms of inputs and outputs, so you get two types of input. So you get sensory information from the spinal cord. That's what's going to help you actually do things like controlling your movement. So proprioception is a really big part of this. So you need to be able to correct movements as you go. So if you're trying to move your arm here, you don't want to be veering off this direction. So if you can feel yourself veering off this direction, your cerebellum is going to tell you, no, you go back the other way. And that will, of course, work even with your eyes closed, because it is not it's not visual based, it's proprioception. Now we do get signals from up in the brain though, because we get motor signals, which is via the actual cerebral cortex and the motor cortex specifically. So that is basically a copy of the signal. So when your motor cortex works, it sends off a signal to your muscles, sure, but then it sends a copy of that signal to the cerebellum. And so that tells the cerebellum, this is what we want to do, basically. And then the cerebellum looks at the input from the sensory, so the feedback from the sensory axons that it gets, and then it says, okay, how does what we want to do compare to what we are actually doing? And then it works to actually correct that. We also have internal signals. So again, once it comes in through those granule cells to the Purkinje fibers, goes down to the deep cerebellar nuclei. And then finally, we output partly back to the brainstem, but probably the most significant output for you guys to be considered about is the thalamus. And so there's sort of two things there, in that when you go to the brainstem motor centers, the cerebellum is signaling the muscles. When it signals to the thalamus, it's basically saying, okay, brain, love what you're doing, but you're doing it slightly wrong. Do it this way instead. So it's a corrective signal. I'm saying, okay, we need to fix it, and this is how we fix it. This is all more detail. You don't need to know most of this stuff. It's just there in case you're interested. I do think that this is a nice little demonstration of what is important to each part of the cerebellum, and then of course how they differ in their outputs, because they do different functions. Okay, now one of the most important things for you to understand is how to do a cerebellar examination, or really how to assess cerebellar dysfunction. So the most important thing for you to get is that, unlike the cerebrum or the cortex, cerebrum, let's say the entire brain up above, that is all contralateral. So your right side of your brain controls your left side of the body, a classic. But the cerebellum is ipsilateral, so it controls the same side that it is on. And so whenever you see a cerebellar sign, it is on the same side as the actual injury itself, okay? All right, so we talk about something called the Danish acronym, which is basically just as Danish, right? Okay, that's it. So the first thing we look at is dysdiadokinesia, which is basically a lack of control of rapid movements. And so you might have seen the specific gesture that we use to test for it. I'll try and demonstrate it here. So we basically do this. So you go palm to palm, dorsum of hand to palm, palm, dorsum, and then you try and do that as fast as you can. So normal people, we can do it really quick. If you have a cerebellar lesion or palsy or something like that, then you're going to be either you're going to do it really slowly, because that's all you can do, or you're going to be all over the place. You're going to be like not coordinated, basically. We also talk about ataxia, which is, again, the sort of clumsiness and lack of control of movements. And so you can see some of this just in your general inspection. So you look at their posture. Are they standing normally, correctly? Is there sort of a lean? Is there any imbalance there? Is their gait weird? And so the broadness here goes for both the posture and the gait. If you are having problems with your balance and your coordination, then you might end up keeping a broader stance because it feels more stable. And so you will see people with cerebellar dysfunction then take that sort of broad stance in order to sort of compensate. And that's a really good sign. Well, it's a bad sign for them, but it's a good way to see cerebellar injury. When they walk and when they pivot, so pivoting and turning is going to be hard for them because it requires a higher degree of coordination, which is why we test it. When they walk, if they have a veer, so if they're going like sort of leaning over to one side and going towards that way, then they're generally going to veer towards the side of the injury. Yeah. So we also talk about the heel to shin test. That one is sort of to do with a couple things. So it's basically mostly coordination. But then we also have something called dysmetria, which is basically, as the name suggests, something wrong. Metria, like you might think of the metric system, so measurement basically. So bad measurement. So they can't accurately estimate and assess distance. So there are two tests we do for this. So there's the heel to shin test, which is they basically lie down with their legs straight, and then you ask them, okay, bend one of your legs and press that heel to the opposite shin. And so that is both a test of how coordinated you are while you're doing it, and also a test of how good whether you have dysmetria, because if you fail to correctly target it, then you might have dysmetria. We also talk about nystagmus, so basically when they try to track slow movement, and it does need to be slow because it won't show up if you do right. So if you do fast movement, but basically when you move your finger really slowly in front of them, instead of their eyes moving smoothly to follow the finger, they go like something like that. So that's why we call it a square wave jerk, because it's like a lot of movement, nothing, a lot of movement, nothing, like that. Yeah. It's important to note with that it doesn't show up in rapid movement, so you need to move slowly. It might also be a bit you might not see it basically when it comes to peripheral vision, so be careful with that. Intention tremor. So we talk about the finger nose test a little bit before, and that is basically they move their finger between your finger and their nose, and that assesses dysmetria, like we talked about before, because they need to be able to actually estimate the distance. And so if they overshoot like that, then you know something's wrong. The other thing that we test is intention tremor itself. So intention tremor is specifically a tremor that you get at the end point of the movement. So they're pretty okay while they go, and then they go sort of a bit of shaking towards the end. And you want to distinguish that from rest tremor, which is they're not doing anything and they get tremor, which is like Parkinson's, and action tremor. So that's while they're doing the actual action, it's all super tremoring, which can also be a sign of cerebellar dysfunction, but it's a bit different. Yeah. When we talk about speech slurring and staccato, those are sort of two different phenomena. So slurring is slurring. Hopefully you guys understand what that means. And then staccato is basically they take words one bit at a time. So you ask them to read the Australian Constitution, and they'll say the Australian Constitution. I'm exaggerating, but you get the idea. And then hypertonia, so just loss of muscle tone. So you guys should already know how to assess for that, but it's basically passive movement. And then you look at how much is resisted on passive movement, which should basically it should be more floppy than usual. Okay. So we have a couple of additional tests that don't test for those specific phenomena in the acronym, but they're still useful. So Romberg's test is not strictly a cerebellar test, but we use it in the examination because it's sort of a coordination thing. And so if you are unable to stand upright, keep your balance while closing your eyes, then the idea is you either or both have lost your proprioceptive function or your vestibular, like ear balance function. And the idea is that the body needs at least two out of vision, proprioception, and vestibular function in order to stay standing. And so if you take out vision and one of the other two is missing, then you'll fall over, basically. If the people are having, like, it's the reason that we say that this doesn't really test for cerebellar dysfunction is that if you had big problems with your floccular nodular lobe, which is the thing that actually controls this sort of movement, then you'd basically just you'd be falling over, because that would be a much bigger deficit. And then finally, rebound phenomenon. So you make the patient sort of press up against resistance, and then when you take away the resistance, so normally you go like a little bit up and then you stop, right? If it's really exaggerated, so you do this and then they go whoop, then that's spasticity. So potentially we have a problem further up in the cerebrum, but not the cerebellum usually. But if they have no rebound, so you press, and then there's no rebound at all, then it's potentially the cerebellar disease. Perfect. Okay, so that basically sums up the function of the cerebellum and how we separate it into those three zones of function. And then the microanatomy, which is mostly concerned with the wiring, how it actually connects to the rest of the brain and the cells involved in that type. And then finally, how to assess for deficit in the cerebellum. And the last thing I'll really want to make sure, remember that it's ipsilateral because people get caught out in that. Perfect. Thanks very much, and enjoy the rest of the week.